Welcome back. Our next speaker is Frederik Ramm, and he's going to be talking about Overpass Turbo Goes PostGIS. Please welcome Frederik Ramm.
Hello, everyone. So, the TLDR of this talk is you can now use Overpass Turbo to not only make Overpass queries, but also make Postgres or PostGIS queries. And in this talk, I'm going to show you how that goes, or a little bit about the history of the whole thing. OpenStreetMap databases, if you want to access OpenStreetMap data in some database form through an API, we've always had the standard API, which we also call the editing API. It lets you do things like, give me all the things in this little square. It used to be that you could use the standard API to do queries like, give me all things that have this tag. But these query modes have been removed or just reduced over time because of performance considerations. In 2007, something called Zappy was designed or launched, where in a custom programming language, you could run queries over larger areas. That was then later re-implemented in Java to make it faster. And in 2010, finally, Roland, who isn't here this time, created the Overpass API, which is in use by many people today. The Overpass API is a separate database that takes its data from the minutely update that Min just mentioned, updates its own local database, and then lets you query that. However, the Overpass API, the Overpass database has its own query language, and this is basically how it looked. When people asked on the help forum, hey, how can I extract all POIs in a certain region? The answer was usually very complex, like, oh, first you have to go to this, and then you get this ID, and then you have to enter this complex query into that form, and then you get a result, and the result's going to be an XML file that you can open in JOSM or something. So Overpass was very difficult to use until in 2013, Martin, who's probably here somewhere, launched Overpass Turbo, which is it's not a separate database. It's just a user interface that makes Overpass easier to use. Many of you will be familiar with Overpass Turbo. That's how it opens up when you go to overpass-turbo.eu, and you can put a query in the Overpass query language in this area, and then you can see your results on the map. From then on, if someone asked something on the forum, said, hey, can someone help me find a way to download this data from OSM? The answer would often be a relatively easy, okay, this is the query that you can use on Overpass Turbo. And I have also stored, because Overpass Turbo has the option of storing a query under a short link. So you can, if you help someone else out and say, this is the query that you can use, you can store that, and people can then just click on that and they get the results. So super great for usability, but people like me were a bit unhappy about that because I'm a Postgres guy. I like using Postgres and PostGIS, and I like using SQL. And I didn't see, why do I have to learn this extra new query language just to access the OpenStreetMap data? And what I would often do is, when someone asks something on the forum like this, how can I do this for all regions? I would often reply, this is a reply that I made like in 2019. I would often say, well, you can solve this problem easily by installing your own Postgres database, downloading an OSM file, loading that into your Postgres database, and then you can run these SQL queries and all is going to be fine. Obviously, the problem with that is most people don't have a fully loaded PostGIS database at hand. Many people won't even be running Linux, so it might be difficult for them to run the utilities. And nobody's stupid enough to run a worldwide Postgres database to just let people run something on that. Maybe not. So I've done something that I call Postpass, which is basically a PostGIS thing, a database that allows you to run Postgres queries, and that's also compatible with the Overpass Turbo. So you can basically replace Overpass API by SQL. On the server side, it's really trivial. It's a very small wrapper around Postgres that just takes queries, executes them, returns stuff in GeoJSON. I run this on the GeoFabric servers because I'm one of the people running GeoFabric, so I have access to lots of servers. But the plan is, if this takes off and if people really like it, then one day it's going to be Min's responsibility, because it's going to be one of the core OSM software projects, maybe. I don't know. Anyway, for now, I'm running this, and I plan to continue running it for a while. Let's see where it goes. This is how you can use it. This is without Overpass Turbo. That comes on one of the next slides. So this is how you could use it with curl. You just say, hey, curl, go to this URL, send this Postgres query, and it will return a GeoJSON feature collection. Some of you will maybe now say, what the fuck? This guy is crazy, because if anyone can execute any SQL statements, then obviously anyone can do something like, little Bobby tables, as you may know it under, like do something like drop table, postpass point or something, and thereby delete the database. Obviously, so that theoretically, yes, because the backend that I've written doesn't parse SQL. No one wants to write an SQL parser. So I just take the SQL query that is sent to me, and I wrap it in some things, and then I send it to the database. But I do the whole thing with a read-only account on Postgres, so the damage that you can do is limited. You can still break some things, but it's more difficult. The most difficult thing is overload protection. So what if someone makes a very complex query, like select everything from postpass point, and then the GeoJSON file is like 400 gigabytes long or something. Or make a very complex join that has to run through all the things. I'm not really solving that. What I'm doing is, I'm first running explain, and I will come to that later. The explain tells me, Postgres will then tell me, okay, this query is so-and-so complicated. It's so-and-so expensive in terms of CPU and disk costs. And what I will then do is, I have 3 queues, a slow queue, a medium queue, and a quick queue. And depending on what Postgres estimates how expensive that query is, it will be put in one of the queues. And the slow queue only has like 2 workers, and the quick queue has, I don't know, 10 workers or something. So if you make a quick query, it will be answered quickly, even if someone else has clogged up the slow queries with their select everything from everywhere queries. And if you make a query like select everything from everywhere, then you will basically sit behind all the other people who have made similar queries, and it will take longer. Yeah, queues for fast queries have more workers. That's how it works, and until now it works reasonably well. I don't know what you will be doing after the talk. Here's a couple of examples showing you how things work in Overpass and in Postpass. For example, this query finds all fast food nodes, all amenity equals fast food nodes in Karlsruhe, so with a given bounding box. This is the same in Postpass, a select query that says, okay, give me everything from the points table that has this tag. Postpass is a slightly slower, slightly faster on this. Some things are faster on Postpass, some are faster on Overpass. We'll see some more examples. The previous query was about points only, nodes only. This is a query that asked about nodes and relations. In Overpass, you would do that by replacing the node with an NWR for node-way relation. In Postpass, you would use the convenience table point polygon, which contains all the points and all the polygons. I'll come to the data model in a minute. Database schema that we're using for Postpass is more or less standard OSM to PGSQL schema. If you have ever used OSM to PGSQL, you know it will create one table for points, one for lines, one for polygons, and they will be, normally they would be called planet underscore OSM underscore point, planet underscore OSM underscore line, and planet OSM polygon. In Postpass, I've chosen to call them Postpass underscore point, postpass underscore line, postpass underscore polygon, but they are more or less the same. They have 4 columns only, a column that's OSM type, node, way, or relation, OSM ID, a column for tags, and a column for the geometry. Unlike the Overpass system, which deals in raw OSM data, this deals, because it's based on PostGIS, this has pre-computed geometry. So it doesn't have to create a polygon from a relation every time you make a query. Instead, the polygons are already in the database. The tags column is a JSON column. That's something that Postgres can do natively. It's more or less like HStore. It's just tiny little bit different in how you access it. And in addition to the basic tables, there are some convenience views that are called postpass underscore point line, point polygon, point line polygon, that will merge these things together. Because otherwise you would always have to build queries that go, select all fast food places from the points table and union that with select all places from the polygon table. And to make that easier, you have these views. The database also has the so-called middle tables. I won't be going into detail about that, but those are the tables that OSM to PGSQL uses to store relationships between objects. So you can know that this relation contains the following ways and stuff like that. You wouldn't normally use them in your queries. Details are in the documentation on GitHub. Yeah. So how does it work with Overpass Turbo? Overpass Turbo has always had a data source selector that in theory would allow you to point it to different data sources. It's not used in everyday use, but when I discussed the Postpass idea with Martin, he said, hey, why don't you use that data thing to basically say to Overpass Turbo, hey, go to this server, and that's what I'm using now. Normally when you talk to Overpass, then Overpass Turbo will have to convert the OSM data that is returned to GeoJSON for display on the map. This is not required with Postpass because Postpass already returns GeoJSON. So on the whole, there were only very few changes necessary in Overpass Turbo to support Postpass, and it's been live since March 2025. So it's had some testing already. This is how it would look in Overpass Turbo. If you made a query like the one we had before, you would put this line in front that basically says, okay, I'm making an SQL query to this machine. This is the URL of the Postpass service. And this is my query. And this, the red B box here, is something where Overpass Turbo then comes in and replaces that with your current viewport. So you can select an area on the map, and then you can just put that into your query. But Overpass Turbo will replace that with a proper geometry that Postgres can then understand. Now I'll just show you that in live and in color. Let me just take this and new tab, Overpass. Okay. So I need to go to overpassturbo.eu. Why doesn't it start? No. There we go. So, and now I'm going to remove this default thing and put my thing in here. So, long time, but this should now work. Let's run it. So it has run the query and come up with some things which will be shown here. Then you can click on that and it will show you all the tags that the thing has in OSM. And obviously I can also do this for other regions. Oh, not that. again. Let's see. So there's a couple of fast food places around here. And you get all your typical Overpass Overpass Turbo features that you have. Look at the details, switch to the node on OSM if you want, and so on. Now, back to my slides. Right. There's also something similar to Overpass Turbo that's called Ultra. And it's based on vector tiles and has some other features. The guy who runs Ultra has also built in support for Postpass. I have some more complicated examples for you. Let me see. Yeah, we still have some time. This is a query that gets us the tram line number 3 in Karlsruhe. So in Overpass, you ask for any relation that has ref equals 3 and route equals tram in a certain area. And the same stuff you can do in Postpass. And the time is at least the same order of magnitude. You can also ask for all tram lines in an area or something that's about similar. Here's a query. I'm going into using these tools for like quality control or finding potential things in OSM that might merit fixing. For example, objects that have an adder : street tag but no adder : postcode. This is something that you can ask for in Overpass. You would use the exclamation mark to say no, not this tag, and in Postpass in SQL you can use tags question mark something or not tags question mark something to ask whether something has a tag or does not have a tag. Here's a query. If you want to find all things that have ref equals 15398, no matter where they are on the planet, it's a relatively simple query in Overpass that takes 300 milliseconds. And it's also a simple query in Postpass, but it takes 300 seconds. So not recommended because of the way the database is built. It doesn't have, it has an index on the tags column, but that index will only help it find things that have a certain tag and not find things where the certain tag has a certain content. So the index will be helpful in finding all things worldwide that have a ref tag, but then it will still have to look at all these individually in a table scan mode, trying to find out which one has the right ref. So Postpass is not well suited for that kind of query. But then again, querying admin boundaries named Manila, this is something where I have created a special index on the database. I can do that as the database admin for some things that I find important. I said, okay, because people will often be searching for boundaries named so-and-so, create an index, and then it's fast enough. Few things about how it works under the hood. I said it's in standard OSM to PGSQL import, the more or less using the Flex backend. There's a small config file that tells OSM to PGSQL how to do it. Uses the EPSG 4326 projection. Has a few special indexes that I have created to make things faster. If you make a query, every database row is wrapped in STS GeoJSON, which makes so Postgres will create the GeoJSON for every object, and then all the rows are merged into a single feature collection using JSON_AGG, which is also a built-in function in Postgres. You can also have queries that do not use geometry at all, that do not return a GeoJSON, but like any Postgres result. For example, this query will give you will look for all the things in the current viewpoint that have an amenity tag and count how many of them there are. Let me quickly run this, try and run this in. Okay. Try this. Right, so I've now counted all the things that have an amenity tag, and Overpass Turbo will automatically notice that this isn't the GeoJSON response, so it switches to the JSON view. And because I put a order by count descending, you can see, okay, there are 67 benches, 52 parkings, and so on in this area. Let's go back to that. Right, so this is possible if you use the GeoJSON equals false flag here, because otherwise, if you don't do that, then Postpass will try and will ask Postgres to build a GeoJSON, and that will then say, sorry, no, there's no geometry in here, can't build a GeoJSON. You can also do aggregation, like any SQL database can do that, where you say, okay, you know, sum certain things up or combine certain things. This is a complicated query that will, I'll go through the details. So this will sum up how many bike parking slots are there within a certain distance of a station. And then we'll return the railway station and the number of bike parkings in the vicinity. So what it does is it's basically using the point polygon table twice. So once for stations and once for bicycle parkings. And it says, okay, these have to be within 0.01 degrees near each other. So 0.1 is 10, so that's 100 meters. So the bike parking has to be 100 meters in the vicinity of the station. And then group by station tags name. So then if you find several bike parkings in the vicinity of the same station, or group that by the station name and geometry, and then sum up the bike parking capacity if you have it. And that will then give you, that will actually return, I'm not going to run this now, but that will give you a map with stations marked. And if you click on the station, you will see, because it says here some blah 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 as cap, so it will then have a property named cap that says the capacity. Here's something. I'm also not going to run this live because it takes too much time. But this query will find overlapping land uses. So it basically takes it's again a self join. So it uses the Postpass polygon table twice, once as A and once as B, and then it says, okay, give me all combinations where A and B overlap, and they both have a land use tag, and then show that to me. This is something that you can easily do in PostGIS or Postpass, because it lets you do geometry operations. It's more difficult to do in Overpass. There's also an explain endpoint, so if you want to toy with this more, and if you build a query, and if you wonder, hey, how long is this going to take, because it looks like a complicated query, you can do a dry run of your query using this the Postgres explain function. This is something that you cannot do via the Turbo API. You have to do that with curl or something. You do not run the API. You don't call the API endpoint, but the explain endpoint. And then you send your query, and then it will return something like this, which means, okay, this is what Postgres thinks it's going to be doing, and this is a science in itself to understand these things, but there are websites where you can actually paste this in, and they will then make a nice graphic for you that say, oh, you've done this, and this is slow, and this is good, and this is fast, la 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 la. And this comes from Postpass, where it says, okay, judging by this, I will put your request in the quick queue, so you're good. Or if it says like queue slow, then you know, okay, this query is probably going to take some time. A quick feature comparison between Overpass and Postpass. Requests with a bounding box work well in Overpass. They tend to be slightly faster in Postpass, but not much. Requests without a bounding box work well in Overpass. In Postpass, they will be slower unless you're doing something where an index has been prepared. Requesting raw OSM data, if you want like the ways or the nodes and the relation objects, because you want to load them into an editor or something, then you're better off with Overpass, because Postpass has the predefined geometries. It basically has dissolved the original objects. If you want to do aggregations, like my counting of bicycle infrastructure, that's good to do in Postgres, more difficult in Overpass. And if you want to do geometry operations, that's also easy to do in Postpass and not as easy in Overpass. I have an extra slide with ideas that where the whole thing could be improved, but I'm at the end of my time already. So if any of you do Go, the programming language, do me a favor, have a look at my source code and tell me if it's worth anything, because this was basically a project where I was teaching myself how to do Go. So there might be some bugs in there that I haven't found yet. Anyway, thank you very much for listening.
Right. Thank you so much for the
Right.
presentation. So now it's time for question and answer.
So can I get JSON sequence as output too?
Can you what?
JSON sequences, like one per line, or do I just have to, as output, just one big JSON?
At the moment, you get one big JSON, but if someone here feels able to build something into Overpass Turbo where that JSON is displayed as a nice HTML table, that wouldn't be impossible, and I'm sure Martin would be happy to take a pull request for that.
Any more questions?
Is it possible to include in the queries conditions on metadata, like last change date or user?
The metadata is not imported into the geometry tables, so it is going to be difficult. It is present in the I'm not even sure if it is present in the middle tables. We'd have to look into that. If you have a use case where you say that would be really good to have, it would be possible to add that. However, you have to remember that in PostGIS we have the geometries already. So say you have the geometry for a building. What would be in the metadata? Because if a node has been moved yesterday by one guy, that could have changed the geometry, but it's not sort of the geometry, is made of many objects. So what would we put in there? It would probably be a list of people and timestamps or something. So it's not impossible, but we'd have to think about how to do it.
Hello. If I have seen this 1.5 years ago, it would be the main source for AutoSM export tool, because we had a lot of challenges with Overpass, and every 2 weeks we will need even to do a restart for our server or a restart for the connection between export tool and Overpass. So what we did is something very similar. So we're currently maintaining a full OSM database with 1 minutely updates, and we created our indexes. But the query coming from AutoSM export tool are more of humanitarian. So the end user don't need to go through like point, polygons, and lines, but they have like a selection for buildings, medical facilities, and others. But how much is this currently in production and well tested? Meaning, if we want to use it as daily queries, because we update HDX data, humanitarian exchange data, based on export tool data from OSM. So we're maintaining this connection. But currently, we're maintaining our database by ourselves. But if we want to move to use Postpass, would that be reliable? How will the production, the production environment is maintained? Is it sustainable on a longer term? What are the queries, the rates, the performance? Do you have those like in production tests yet, load tests?
I have launched this thing at a German conference in March and asked people to run some tests on it and try and break it. They haven't managed to break it yet, but maybe you will. I would not recommend to use this in production, because I might change it it's possible that someone comes along and says, you know, maybe we would like to have this or that or something different, and then we might just make a change. It's a young project after all, and if you have a use case where you basically need your system to be working and you don't want to sort of, oh, why has it stopped working? Oh, Fred has changed his thing. So, you know, it's for me, it's, even though I run it on GeoFabric service, it's a hobby project, and it might change, it might break, it might, so. Thank you. Okay, we need to stop the questions here, but I'm at the conference for until tomorrow. So if there's anything that you're interested in, feel free and hit me up for questions. Thank you.
All right, thank you.